Hi everyone, my name is Elijah Navarro, and for week number 5, I will be doing a lesson on section 1.6, which is based on the product and quotient rule. So, to start off this lesson, I would like to give a very significant and relevant definition to our lesson, which is the definition of a product rule. So the product rule is used to find the derivative of a function that is the product of two other differentiable functions. So for example, if you have the function h of x equals f of x multiplied by g of x, the derivative of that function would be h prime of x equals f of x, f prime of x, g of x plus f of x, g prime of x. So to get deeper into this whole lesson and break things down first in terms of just making it simpler, I'll be putting this into easier terms to just essentially make it easier to understand. So I would want you to think of this as a first times derivative of second plus second times derivative of first sort of situation, just because the derivative of a product is the derivative of the first function times the second function plus the first function times the derivative of the second function. So now you may be wondering, why does the connection to the rate of change and the product rule itself, work? So this rule arises from the limit definition of the derivative and can be understood by considering how small changes in f of x and g of x affect their product h of x. When you're looking at the instantaneous rate of change of a product, both components are contributing to that change simultaneously, and the rule basically accounts for the change contributed by f of x, while g of x is held constant momentarily, and the change contributed by g of x while f of x is held constant. So we're going to get into an example. So we are going to be finding the derivative of y equals x squared sine of x. So we see that f of x equals x squared and g of x equals sine of x. And we can recognize that f prime of x equals 2x is using the power table rule, and g prime of x equals cosine of x is a standard derivative. So when we apply the product rule, this results in ultimately y of x equaling f prime of x g of x plus f of x g prime of x, and then y prime equaling the quantity 2x and sine of x plus the quantity x squared and cosine of x. And then ultimately it results in y prime equals 2x sine of x plus x squared cosine of x. So that is half of our lesson on product rules. Now the other half of our lesson will be on the quotient rule. So to get started here, we can say that the quotient rule, another important definition that is equally as significant as the product rule in this lesson, is the quotient rule is primarily used to find the derivative of a function that is the quotient, for example, division, of two other differentiable functions. So for example, if you have the function h of x equals f of x over g of x, the derivative of this function would be h prime of x equals f prime of x g of x minus f of x g prime of x to the quantity of over the quantity of g of x squared. So we're going to do a breakdown again and explanation again, basically the same process that we went through last time with the product rule. So let's answer how can this be explained in simpler terms, and if any confusion may be lingering, this is how I would put it. So basically, we would think of this as the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So that is how we can put it in terms of mathematics, but why else would this quotient rule work in connection to the rate of change? So similarly to the product rule, the quotient rule is derived from the limit definition. It's more complex because you're dealing with the rate of change of a ratio. The rule carefully balances the contributions of the numerator's rate of change and the denominator's rate of change, ensuring that the overall rate of change of the quotient is accurately captured. So the subtraction accounts for the diluting effect of the denominator changing. So an example that we will give and look at is finding the derivative of y equals e to the power of x over x to the power of 3. So we see f of x equals e to the power of x and g of x equals x to the power of 3. So we figure that f prime of x equals e to the power of x is the standard derivative in this case, and g prime of x equals 3x squared is using the power rule. So when we apply the quotient rule, y prime equals f prime of x g of x minus f prime of x g prime of x over the quantity of g of x squared ultimately results in y prime equals e to the power of x and x to the power of 3 minus the quantity of e to the power of x 3x squared over the quantity of x to the power of 3 squared. And my apologies, I would like to re-say this, but you guys see the visuals. It is unfortunately a little bit overwhelming when you have everything right in front of you, but this is the lesson on our product and quotient rules, and I really hope that this lesson was helpful and I broke it down in a way that is easier to understand. Thank you for watching.